To have students confirm the calculated volume of their cylindrical object, they can actually measure the volume by the displacement of water. We'll take some water in a graduated cylinder, and I have here 67 milliliters. Now I can lower my candle into the water. So we start with 67 milliliters, and now I just make sure I press it just underneath the water surface. And here it's at 97. So that means that the volume of the candle is about 30 milliliters, the difference between the two. And you can then compare that with the calculated value for the volume. Now you'll find often that the volumes may differ by a few milliliters, and that's due to what we call experimental error, because every measurement has associated with it an error. Students may read the scale a little bit incorrectly. They may make a mistake in reading the volume, or are not able to read it very precisely. And so with experience, that experimental error will decrease. And so it's good practice for students to use both techniques, measuring the volume by displacement and calculating the volume using a ruler and the appropriate formula. What do we do with objects that are larger than our graduated cylinder? How can we determine the volume of that? Well, we can make ourselves an overflow can. And what I have here is just a can, and you can use any kind of can that is convenient. And what I've done here is punched a hole in the side of the can and enlarged it so that this piece of Tygon tubing will fit snugly in the hole, and then I sealed it off with some glue from my glue gun. So here's one in which I've used Tygon tubing. Here's another one in which I used some rigid plastic tubing. Either one of these will work fine. I place my can on a stand and then add water until it overflows. And we then allow the water to run out until the water no longer flows. Once it stops dripping, we then take our graduated cylinder and place that under the spout and press our object under the water and allow the water to flow until it again stops dripping. And once it stops dripping, we can then record the volume of water from the graduated cylinder, which then gives us the volume. We can again determine the mass using our balance, and from that we can calculate the density. It's important to determine the mass of a dry object, because obviously the mass will be increased when the object is wet. One of the problems of using water as a displacement agent is that its surface tension is quite high, and it can actually form large drops in the tube, which will make it difficult for the water to flow out. To reduce that surface tension, you can add a small amount of dish detergent to the water, which prevents the water from actually plugging up the tube and it makes the displacement of the water a little bit easier. So let me just repeat that using the styrofoam ball. So just a simple modification to reduce the surface tension of the water. Let's use this method now to determine the density of this rock. I've attached a string to the rock so I can lower it into the water gently. I've already determined the mass, and so I'm going to place under here a graduated cylinder, a 250 ml graduated cylinder, because I know that the volume is a little bit more than 100 milliliters. And so now we'll lower it into the can. And it doesn't really matter how far we lower it, so we can just let it sit in the can and keep the string on the edge, and then allow the water to drip out. So the rock has a mass of 356 grams. And so the density is 356 grams over 126 milliliters, grams per milliliter. And so we see that the density of rock is significantly greater than the density of water, 2.8 times as dense, which is of course what we would expect, because a rock contains more matter per unit volume than does water. And so we say that a rock is heavier, and really it's correct, we should say a rock is more dense than water,